Good morning, students. Today we start the new chapter of the physical chemistry known as electrochemistry. Electrochemistry is a branch of the physical chemistry which generally deals with the relationship between electrical energy and chemical energy change which is taking place in the redox reaction. That is how electrical energy produced in the redox reaction can be converted into electrical energy and how electrical energy can be used to bring about the redox reaction which is non-spontaneous in nature. As we know that the electrochemistry generally have three main aspects. Number one, electrochemical cells, electrolytic conduction and electrolysis. What is the importance of electrochemistry? The importance of the electrochemistry are in the production of number of metals like sodium, magnesium, calcium, aluminum, and number of the chemicals like NaOH, chlorine, fluorine, etc., batteries, and in the fuel cell, which converts the chemical energy into electric energy, and the various reactions which are carried out in electrochemical methods are the energy efficient, less polluting, and eco-friendly. Especially the transmission of the sensory signals through the cell to the brain and vice versa, the electrical chemical origin will also take place. Therefore, in electrochemical cell, which is a device in which the chemical energy is converted into electrical energy, are generally of the two types. Number one, which is said to be the galvanic cell, other is said to be the electrolytic cell. In galvanic cell, a spontaneous chemical reaction generates an electric current, while in electrolytic cells, an electric current drives a non-spontaneous reactions. Now, if we want to construct the electrochemical cell or the galvanic cell, first of all, we have to study about how the potential or the charge is developed over the metal electrodes. Now, in this case, suppose when zinc rod is dipped in the zinc sulfate solution, the metal atom have a tendency to go into the solution. The electron remain on the zinc rod, it become negatively charged with respect to the solution. To balance the negative charge, a layer of the zinc ion is formed around the zinc rod. Thus, the electrical double layer of the electron and zinc ion is formed around the zinc electrode. The formation of the electrical double layer is responsible for the potential difference developed between the solution and the metal electrode. In the similar way, now when copper rod is dipped in the solution of the copper sulfate, the copper ion have a tendency to be deposited on the copper rod. The metal cation take electron from the metal rod, thus the copper rod become positively charged with respect to the solution. To balance the positive charge, a layer of the sulfate ion is formed around the copper electrode. Thus, an electrical double layer of the copper ion and the sulfate ion is formed around the copper electrode. In this way, we are able to get the electrode potentials established between the metal electrode and the metal ion solution. Now, this electrode potential is generally originated when the metal rod is dipped in the solution containing of its own ion. A potential difference is produced between the solution and the metal rod. The potential difference developed is known as the electrode potential. Now, in the case of construction of electrochemical cell, when the zinc rod is dipped in zinc sulfate solution and the copper rod is dipped in the copper sulfate solution. Now here, these two electrodes are connected through the galvanometer by the metallic wire and the electricity began to flow. The zinc rod acts as anode and the oxidation occur at the electrode, and copper rod acts as a cathode and the reduction occur at this electrode. The oxidation and reduction reaction takes place in the cell, and the sum of the two half cell reaction is complete redox reaction taking place in the cell. Now, zinc electrode, the oxidation occur at this electrode, it is anode and negatively charged. Copper electrode, reduction takes place and it is positively charged. The electron flow from anode to cathode and the current flow from cathode to anode. Now, when the concentration of both zinc ion and copper ion is 1 molar, the EMF of the cell is 1.1 volt. Now, if the concentration of the copper ion is increased and those of the zinc ion is decreased, the EMF of the cell increases. Now, if an increased external opposite potential is applied to the cell, the cell reaction continues till the opposing voltage is less than 1.1 volt. Now when the opposing voltage is 1.1 volt, the reaction stops altogether and no current will flow. Now when the opposing voltage is greater than 1.1 volt, the reaction again starts but in the opposite direction. It is the non-spontaneous reaction. The electrical energy is used to carry out the non-spontaneous reaction. Now what is salt bridge and what is its function? A salt bridge is a U-shaped tube containing saturated solution of potassium chloride or a potassium nitrate or potassium sulfate and having agar-agar or gelatin. The inert electrolyte does not take part in the reaction. It is also does not react with the electrolyte present in the cell. It allows the flow of the ion from one half cell to the another half cell without mixing the two solution. It completes the circuit and allow the current to flow. This is the first function of the salt bridge. The another function is to maintain the electrical neutrality of the solution of the two half cell. To maintain the electrical neutrality, the cation and anion present in the salt bridge moves toward the solution. Now, the electrode potential, that is the driving force that pushes the negatively charged electron away from the anode and pulls them toward the cathode in an electrical potential called electromotive force, is also known as EMF of the cell voltage. The potential difference which is developed between the metal electrode and its ion in the solution is known as electrode potential. This electrode potential will depend upon number 1, concentration of the solution, nature of the metal, nature of the electrolyte, and the temperature condition and the pressure condition. Now, the potential difference developed between the metal electrode and the solution of its ion at 1 molar concentration and 1 bar pressure at 298 Kelvin is known as standard electrode potential. Now there are two types of electrode potential. One is known as oxidation potential, other is reduction potential. Now the oxidation potential, greater the oxidation potential, greater is the tendency to get oxidized. The greater is the reduction potential, greater is the tendency to get reduced. Now the cell notation of the galvanic cell. In the galvanic cell, we have to remember the following rule. The anode is always written on the left hand side and cathode is always written on the right hand side. The separation of the two phase, the state of matter is shown by the vertical line, while the various material present in the same phase are shown together using commas. The salt bridge is represented by the double slash. The significant feature of the substance, that is pressure of the gas, concentration of the ion, etc., are indicated by the bracket immediately after writing the substance. For the gas electrode, the gas is indicated after the electrode for anode and before the electrode in the case of the cathode, that is platinum electrode, hydrogen / H ion or hydrogen ion / H2 platinum electrode. The anode half cell is represented as copper solid / that is the phase boundary copper ion aqueous 1 molar salt bridge Cl2 gas 1 atmosphere / phase boundary Cl negative aqueous 1 molar ion. Now calculation of the electrode potentials. Suppose when the metal is placed in the solution of its own ion, the electrode is represented as metal / metal ion. The potential of this single electrode cannot be determined because the two electrodes are required for the complete cell. Therefore, we need one more electrode whose potential is known. The EMF of the complete cell so formed is determined. The EMF of the cell is equal to the algebraic difference of the reduction potential of the two electrodes. That is, E cell is equal to E cathode minus E anode. Therefore, to determine the electrode potential, we have to connect the electrode potential with the She, and the EMF of the complete cell is determined experimentally. Since the electrode potential of the She is 0, therefore the value of electrode potential is determined is equal to the electrode potential which has been connected with She. Now, what is a standard hydrogen electrode? To prepare this standard hydrogen electrode, hydrogen gas at 1 atmosphere pressure is in contact with H ion having a concentration of 1 molar and a platinum wire which is connected with platinum foil coated with platinum black, dipped in acid solution whose concentration is 1 molar. Hydrogen gas is 25 degrees centigrade and 1 atmosphere pressure is passed. The hydrogen gas is adsorbed on the platinum plate. Does the hydrogen gas remain in contact with H ion? It is like the electrode in which the metal is in contact with its own metal ion. Now, the standard hydrogen electrode act as anode as well as cathode. Now, when it acts as cathode, the reduction takes place on it. Now, when a standard hydrogen electrode acts as anode, the oxidation occur on it. Suppose we want to determine the standard electrode potential of the zinc electrode. The concentration of the metal ion is kept at 1 molar. This electrode is connected with She by using the salt bridge. Now, in this case, the zinc electrode, the oxidation occur at this electrode. It is anode, negatively charged electrode. Reaction is Zn change into Zn plus 2 electron. And hydrogen electrode, the reduction occur at this electrode. It is cathode, positively charged. Reaction is 2 Hin plus 2 electron changing into H2. The net complete reaction is Zn plus 2 Hin changing into Zn plus 2 plus H2. E cell of this electrode has been determined experimentally. Its value is 0.76 volt. Now the E cell is equal to E cathode minus E anode. Now the E cell which is determined experimentally is 0.76 is equal to 0 minus E naught zinc. Now therefore the E naught zinc is equal to minus 0.76 volt. The negative sign of the E naught for zinc shows that on connecting zinc electrode with She, the oxidation takes place at zinc electrode.